Hey, I have an interesting problem, or at least I think so. We're given a polynomial, and we're told that the zeros of the polynomial are A, B, and C. And without actually computing A, B, and C, you're supposed to evaluate this expression that depends on A, B, and C. Okay, so that's the goal here. And again, you technically, I guess, you could use Cardano's formula, find A, B, and C, and do this the long way, or you could use this approach attributed to Vieta. Now, just a little bit of information on this result right here. These minus signs alternate here in front of these values, sigma 1, sigma 2, and sigma 3. Now, y'all, I'm using slightly different notation. These are called the ESPs, the elementary symmetric polynomials. Let me get the marker working here. Again, folks, this row right here is called the elementary symmetric polynomials. I guess some elementary symmetric functions, polynomials. So ESP, not extrasensory perception, although I could use that about right now. So this sigma 1 is the sum of all distinct products of one variable, sum of all distinct products of two variables, and the sum of all distinct products of three variables. And these are the zeros of the polynomial, by the way. But there's only one distinct product of three, there's three distinct products of two, and there's three distinct products of one if you want to think of A as being a product or B being a product. Now, so right up here, when we're given that A, B, and C are zeros, that means that for this polynomial, you could write x minus A times x minus B times x minus C. All right. Now it's clear that there's zeros when you just set this equal to 0, right? Okay, y'all, and that does read x minus C right there, x minus B and x minus A. Now, this helps you to understand why this minus sign appears, right? Because no matter what A, B, and C are, you're going to have, when you multiply this out, you would still have that minus sign in front. And this can be kind of confusing. Often people, sorry, y'all, let me, I can't really erase that, sorry. But, so this reads ABC here. And notice you see again the presence of 1, 2, 3 right there ensures this minus sign is going to be here no matter what the values of A, B, and C are, okay? So that is why the minus sign is there. And it's similar all the way across why the minus signs alternate, okay? And so that's kind of useful to see. That kind of makes you trust. You know for a fact that if you expand this out, you would have minus A, B, C at the end. But notice how we defined sigma 3. Sigma 3 is defined to be A, B, C. All right, so that's kind of cool. Now, we're actually supposed to evaluate this expression right here. And it turns out, let's see, I think we can factor some things out of here. In other words, if you take a look right here, you could rewrite this as, you can factor an A squared out of this, right? So you would have A squared. And y'all, you can do the very same thing if you factor B squared out. And then you can factor a C squared out right here, right? All right, so let's envelop that in parentheses. But what's left over in each case? See how convenient this is? This works out kind of nicely. We get A, B, C, right? But notice ABC is just sigma 3, all right? ABC is just equal to sigma sub 3. All right, and down here, we will show that a squared plus b squared, you see a squared plus b squared plus c squared, okay, that's just equal to sigma 1, sigma sub 1 squared, right? That's this piece right here. Gosh, oh, please just work. This pen is so miserable with Zoom. I hate to keep complaining about it, but it's sorry. I don't know how Zoom got away with making something that's sloppy. All right, now minus 2 times, you see now that's going to be your sigma 2. That'll be sigma 2. Y'all, again, I apologize. That's very sloppy. But so your a squared b squared plus c squared is equal to sigma 1 quantity squared minus 2 sigma 2. But you see, we're given all of that information here. You see, we're given every bit of that information. And so this all would add up. You can see the work right here. This all would come out to be minus 2. Okay. Again, I hope that's legible, folks. This reads sigma 1 squared minus 2 sigma 2. Okay. Now, right here, though, we already know that ABC is equal to 4 from the Vieta's result. And so what we get right here is that this piece right here is equal to 4. Right. And again, I hope it's readable. I really am. And we've just shown that a squared plus b squared plus c squared is negative 2. Okay. So we actually get, and this is going to be the final result right here. We actually get that the answer would be minus 2 times minus 4. I'm sorry, minus 2 times plus 4, y'all, because of the sign, right? Okay, so that's minus 2 times plus 4, for emphasis there, equals to minus 8. And y'all, this is the final answer right here. Oh man, that was sloppy, but I think it's readable overall, right, folks? Okay, y'all, I hope it helps. So the answer to this calculation is -8 without actually having to have computed the values of A, B, and C directly. Okay, thanks.